Here in this video, we are solving two questions that appeared in NEET 2024 from the chapter Atoms. Let us see the first question. Atoms are electrically neutral as they contain equal number of positive and negative charges. This is correct. There are electrons orbiting in the nucleus. Around the nucleus. There are protons inside the nucleus. Protons have a positive charge, electrons have a negative charge. Thus, both of them are cancelled. So, it is neutral. So, this is a simple correct statement. Statement 1 is correct in every place. And you look at the second statement. Atoms of each element are stable and emits their characteristic spectrum. This is the problem actually. So you need to be careful that atoms are stable, not each of them. Most of them are stable. There are some elements like radioactive elements like thorium and all, like polonium. They emit radioactive emits from their nucleus itself because they are not stable at the nucleus level. They emit a characteristic spectrum is fine, but not each of them are stable. Most of them are stable. So the second statement is wrong. Thus this question became a big controversial question. Even Supreme Court has made a committee on this, Delhi IIT, and they have also said the same. The problem is the old textbook said that each of the elements are stable, but the new textbook, NCERT textbook, says that most of them are stable. So we'll stick to the answer that most of them is stable. Each of them is stable is not guaranteed. So this second statement is wrong. First statement is correct. Second statement is correct means this option is wrong. Statement both 1 and 2 are incorrect. That is wrong because 1 is right. Statement 1 is correct and statement 2 is incorrect. That option 3 is right. Statement 1 is incorrect is wrong. Statement 2 is correct is also wrong. So option 3 is the answer for that question, right? Let's have a look at the next question. Spectral lines of hydrogen spectrum transition from given, their wavelengths are given. One thing you can notice is all of them n1 equal to 2. So if you remember the equation that we have derived for de Broglie, Bohr's atomic model, 1 by lambda equal to Rydberg constant of 1 by n1 square minus 1 by n2 square. For all of them n1 equal to 2 means, so there are different series like Lyman Balmer. n1 equal to 2 means it is Balmer series. n2 will be greater than this 2, 3, 4, 5 onwards and all, right? So if you substitute the values further, 1 by lambda equal to Rydberg constant is 1.097 into 10 power minus 7. n1 is 2 square minus n2 is, I will try for the least or the first option, 3 square. So if you calculate this value and get the value of wavelength lambda, Rydberg constant is 10 power plus 7, not minus 7. So if you reciprocate it and calculate the value of lambda, you will get it as 65, approximately something like 6563 angstrom. Answers are given in nanometer, so that's going to be 656.3 nanometer. So the first one is this. A shall be having an option 3. Fortunately, there is only one option having, so that's the answer itself. But you can reason out like further, like how do we get that answer? See, 1 by lambda equal to Rydberg constant of 1 by n1 square, that is n1 square is of course 2 square in all the case. This could be n2 square. In the place of n2 I have written 3 earlier. That means if I have written 3 it becomes 1 by 9. If I have written 4 it becomes 1 by 16. So if I compare these two in the second part of the equation, as the denominator increases, when compared with this part, this fraction value reduces. As that fraction value reduces, the subtracting part gets reduced. So this entire value, subtraction value is reduced, and this entire value increases. As that entire value increases, 1 by lambda also increases. As 1 by lambda increases, lambda decreases. Thus, when you move further from 3 to 4 onwards, lambda has to decrease. So the nearest value for the next 4 is this. I mean, among them, the decreased value, the least decreased value is 486. So for the B, it has to be 4 and so on. So this option can be easily locked as a confirmed answer. That's how we solve these two questions from atoms. Thank you for watching.